Coral reefs, beautiful structures built by millions of tiny polyps who lay down their hard limestone skeletons, fantastic flamboyant shapes and beautiful colors, homes to countless beautiful fishes dancing above the coral fingers, ready to hide in the crevices formed by the corals should a dangerous predatory fish approach them with hungry intentions. There are few things formed by organisms on planet Earth which should really be called planet ocean, as fantastic and breathtaking as coral reefs. Let's talk about coral reefs in this documentary from the amazing waters of the Philippines.
No, let's instead talk about muck diving. Muck is not a very nice word. It means something like filth or dirt. This is a typical muck diving dive site. There's really not much to see at a first sight. But what if you look more closely? There is actually a multitude of amazing critters, which are expertly adapted to thrive and survive in these underwater sandy plains, in these soft bottom environments. In this documentary, I want to convince you that in these muck diving sites there is a very unique specialized fauna of animals which employ a lot of very clever evolutionary tricks to survive in the muck. To my scuba diving friends, I want to tell you more about the biology of these prized sought after critters. To my marine bio friends, I want to tell you that there's a habitat, the muck, which deserves more attention than it generally gets. And to everybody else, please take in the images of these fascinating and often bizarre looking critters. These are jackfish, fast, clever predators, and there are many of them. They have a keen sense of vision and hearing, and they can detect water movement generated by their prey by using the lateral line organ. How can you get away from them if there's no place to hide? If you're in the muck, imagine being a small fish in this underwater sandy plain. And then you see these coming. What do? You will need some special tricks. Mother Evolution had to work long and hard to optimize a fauna of organisms so that they can survive in the sand. The trick which comes to mind first is camouflage. Let's look at camouflage in muck habitats more closely. The most commonsensical approach to blend into your environment is to camouflage yourself. Do fishes and crabs have common sense? You'll be the judge. This is a small goby. Not only does its color match the sand, its texture matches the sand too. The same with this one. This flapping of the pectoral fins seems to be a communication signal between this one and another goby. They don't want to be invisible to everybody. Another strategy to be better camouflaged is to be very flat. This is an elbow crab. It's so covered in sand that it's hard to distinguish from the bottom at all, especially if it doesn't move. Now, crabs generally are masters of camouflage. There's a whole group of crabs called the decorator crabs. They put stuff, all kinds of stuff, on their backs, and that provides a shield, but it also breaks up the crab shape. This looks like a moving log, not particularly like a crab. The log is also covered in hydroids, stinging animals. This crab has a body shape, which makes it look like a piece of rock. It just moves a very little bit, and it's also covered in hydroids, these stinging animals, somewhat related to jellyfishes. And there's another one like this. Again, it's densely covered in sand. Covering yourself in sediment, as well as with other marine animals, seems to be a preferred strategy among these crabs. I should add, I saw this one at night. So, what are the chances of a predatory fish seeing this crab when all the light available is a little bit of moonlight? Crabs are fearful animals, and they have developed into masters of camouflage. Another group of animals which are highly camouflaged are these frogfishes. You just saw the mouth when the animal was yawning, and just above the mouth, one of these dots, the one moving a little bit, is the eye. The whole animal looks like a rock that's covered in purple and red sponges. Sometimes, and I don't think this is a boring topic at all, it's difficult to gauge what is a part of the animal and what is a part of algae overgrowth or sand that got stuck to the frogfish. Frogfishes come in all kinds of colors and textures, and even though some of them are about the size of a volleyball, they're very hard to find underwater. A lot of the relatives of the frogfish are deep-sea anglerfish, which live several hundred to a few thousand meters deep in a region of eternal darkness. The shallow water relatives in the frogfish family had to camouflage really well. Now this is a completely different fish. This is a leaf scorpion fish. And what is this? There's a big bush of black coral. And what's the piece in between? Is that a piece of detached black coral? No, this is a ghost pipefish, a harlequin ghost pipefish. These animals are distant relatives of the seahorses. And they're probably, at least for my taste, one of the highlights of vertebrate evolution. This fish has modified in evolution its body to such a degree that it really looks like a piece of invertebrate. Either this black coral here, or it also fits in really well with sea feathers, with crinoids. You can see the eye of the fish, it's moving here. And this is a especially skilled master of camouflage. This is the mimic octopus. The mimic octopus is not camouflaged primarily by its looks, but by its behavior. Right now, it's somewhat pretending to be a flounder, a spiny fish, which is not very good eating for predatory fishes. The mimic now, it's probably mimicking a sea star or a lionfish. The mimic octopus camouflages itself by shaping its body like spiny or venomous marine animals. Camouflage is not a simple strategy. And there's one more chapter in camouflage which we will look at next. Human hair is meant to keep us warm, and it also shows beauty and vitality. Now there are some very hairy critters in the muck, and their hair fulfills a very different role. This is an ambon scorpion fish, seen at night in a muck area on Negros Island in the Philippines. Why is it hairy? It's mimicking a ball of algae. There's reddish and brownish filamentous algae all over these muck diving sites, and they grow quickly on an exposed rock. The ambon scorpionfish, here traveling as a pair, is mimicking this. This is a sea hare, and of course that's a very different animal than a scorpionfish. It's a mollusk, a sea slug related to our garden slugs. The mimic of algae is the same strategy employed by the ambon scorpionfish. We have a prime example of convergent evolution here. Evolution started with a fish body and with a sea slug body, and they both became balls of hair, meant to look like algae-covered rocks. It's really hard to spot these animals without a video light and when they're not moving. This is a crab, which again employs the same strategy. It looks hairy, and it's actually probably overgrown by algae, plus covered in sand. Unless it's moving small edible particles to its mouth, it's very difficult to discern that this is an animal. What a brilliant strategy. This is a small animal, less than 5 centimeters across. A different crab, same strategy. And the small lionfish, it's a dwarf lionfish here, is actually confused why this algae-covered rock is moving. It's not possible to look into the head of the fish, but I would think that the camouflage worked on that fish. Right next to this predatory fish, the algae is feeding and picking off little pieces of algae of this Halimeda. Now, yet another crab, densely covered in algae and looking very hairy. Yet another example of convergent evolution. The ancestors of the sea hare, of the crab, and of the ambon scorpionfish were not hairy at all. But the strategy is so useful in the muck that it evolved independently several times. It is my observation that crabs are very fearful animals. Say you find a mangrove crab, it will immediately take off when it sees you as a human and as a potential predator. Now, this predominant fear in the behavior of these animals has guided their evolution, and crabs have become masters of camouflage, of disappearing under the sand, and they have sometimes developed really bizarre body shapes in the service of camouflage. Muck habitats are prime habitats for these highly camouflaged crabs. Hiding under the sand. Another very commonsensical strategy when you live in the sand. A lot of different animals in the muck have evolved this strategy. Here's another crab, which decided to disappear upon seeing me. And here a pygmy squid does the same thing. Just like with camouflage, hiding under the sand has evolved convergently. Animals which are only very distantly related, like crustaceans and this mollusk, this cephalopod, are using a very similar strategy. Now, if you as a human being weighing, let's say, 70 kilos, being 1.70 meters tall, try to dig yourself into the sand, it will be difficult. You need time and you need a shovel. Why does this work so much easier for the small critters? Well, when you're small, the physics are a little bit different. Also, underwater, the physics are a little bit different. The buoyancy of the water makes all these sand grains lighter, and they're less like rocks and more like bouncy balls. Also, when you're small, any liquid becomes, relative to your body size, more like a viscous fluid, like honey. You have a smaller Reynolds number. The Reynolds number is the crucial number in fluid dynamics, named after Osborne Reynolds, the Irish physicist. Here's another animal deciding that it would be a good idea to get away from my video lights under the sand. You can see that I filmed this at night because of the storm of tiny crustaceans which my video light attracted. This is a pleuroprank, a type of sea slug related to the nudibranchs. The species is Pleuropunkia brocki. You can see the peristaltic movements in the body of this animal. It's going to go where I can't see it anymore. Covered by just a couple of millimeters of sand, but invisible to the underwater videographer and invisible to any predator which might come along. It's probably not particularly sophisticated what triggers this behavior. It's just light. Obviously, I was filming this with a video light, and the animal wasn't aware of the technology mounted on my camera rig, but it just in some vague sense decided it was day again and it had to disappear. On any muck dive during the day, you're probably swimming over a massive fauna which you don't even realize. A brittle star just came by, and more of these tiny crustaceans. The pleuroprank is just halfway in the sand now. There is another sea slug. It's a so-called head-shield slug. Again, very quickly, upon noticing that there was somebody nearby with a light, it decided it had to disappear. And again, look at the size of the sand grains in relation to the small animals. This is a very different situation, as opposed to a human trying to dig himself in. Small is an advantage when you're digging under the sand. This is probably one of the reasons why there are no really large animals in the muck. Another pygmy squid. Note the siphon, which is sticking out. And I really love these. These are the so-called sand divers. Yet another fish deciding that it needs to be underwater, in the sand. And these guys are the kings of hiding under the sand. These are garden eels. These are sessile vertebrates. After their larval stage, they never leave their burrow. When they are left alone, they forage for plankton from the midwater. When anybody approaches them, they retract into their burrow. These are the total opposite of an albatross, which might fly thousands of kilometers during his life. They don't move at all, and even when they mate, they just mate with their neighboring eels. Behavior is one of the main drivers of the evolution. It's rarely ever as clear as in the case of these garden eels. It's getting dark, the end of the day. You have probably already noticed that a lot of the footage I present here are shot at night. The muck is more active at night. But is it also getting dark for biodiversity on planet Earth? On a lot of muck dives, you see trash, rubbish. They're no more functional end products of human civilization. When there's only sand and not a lot of structure, a lot of the human trash stands out. This is the same everywhere these days on planet Earth. Bizarrely though, in the muck ecosystem, a lot of animals use the products of human civilization. These lemon gobies, Lubricogobius exiguus, are lucky. They use a piece of plastic which used to contain an instant soap mix. They perch on it and they breed on it. It's something that muck divers observe very frequently. That some of the rare and unusual creatures of the muck, very desperate for any kind of protection, use human trash as homes. This porcupine fish is spiny, and it's even more safe in a broken up bottle, its sharp edges protecting it even more than its spines. Fish are smart. Not everything that's man-made underwater is trash. This is a mooring block in the muck, and it very quickly becomes a marine life magnet. This mooreel calls it its proud home. There's a variety of structures which is related to shipping traffic. Mooring blocks, mooring lines, and unfortunately also ghost nets, discarded nets, which are no longer serving to catch fish for humans, still end up on the ocean floor. This mooreel is lucky that it hasn't been caught in one of such nets. This is a mooring line. These odd fishers are razor fishers, very distant relatives of the seahorses. The invertebrates on the mooring line for them to eat, and the line also is a cover. In the early 21st century, humans dominate almost every aspect of life on planet Earth. And they do it in the muck habitat in very peculiar ways. When you're poisonous, your attacker is in trouble when he eats you. When you're venomous, like the striped eel catfish, the attacker is in trouble when he touches you. Both are common in the muck. This is probably the most unusual example of the action of venom I've ever seen. A poisonous and venomous pufferfish with venomous catfish stuck onto it. The catfish got the shorter end of the deal, and it seemed they're dying or they're already dead. Stonefish and scorpionfishes are very venomous by means of the dorsal fin spines and are frequently seen in the muck. These fishes are often really beautiful gems of the muck. They don't swim very fast, because if you're that venomous, you don't need to get away from your predators. This is a spiny devilfish, or sometimes also called the Indian walkman fish. It just yawned, probably a warning to a videographer which came too close. The dorsal fin spines of this fish can be deadly. Another warning, showing the warning coloration on its pectoral fins. Interestingly, this fish prefers to walk, not swim. Again, if your venom makes you so extremely dangerous, there's really no need to swim and to be fast and to escape at high speed. Again, what a beautiful fish. Or let's put it this way, what a fish with character. You can see that it's walking by moving the first two spines of its pectoral fins. This fish uses several of the muck strategies. Not only is it extremely venomous, but it also digs itself into the sand. This is a flatworm. What a gaudily colored invertebrate. Why these strange colors? Well, they are warning coloration. Fishes and other predators of invertebrates will learn that anything with such a striking color is probably very poisonous. These flatworms in some cases use tetrodotoxin, the same toxin which is also contained in the pufferfish, which is produced by bacteria in the environment and then taken up by these poisonous animals. There are more interesting things going on. Some of these flatworms are not poisonous themselves, but they mimic poisonous nudibranchs. And of course, every muck diver loves nudibranchs. Beautiful colors and an amazing biodiversity with several thousand species in the tropical Indo-Pacific. Not all of them are poisonous, but many of them are. And it's quite likely that this explosion of biodiversity has to do with their ability to defend themselves, even though they're soft and small. And finally, a decorator urchin. Sea urchins are spiny and dangerous to begin with. But this flower urchin also contains a venom which will cause respiratory problems in humans. Here's a close-up of the spines. Venom and poison, common in the muck. When you are having a hard time making it alone, work together. Symbiosis, a very common strategy in the muck. This tiny shrimp lives in between the branches of a soft coral. The most fascinating symbiosis in the muck, at least to me, is the one between shrimp and shrimp gobies. Gobies are tiny benthic fishes with big eyes. There are many hundred species of them in the tropical Indo-Pacific, and about 120 species of them have decided to team up with a shrimp. They use their big, keen eyes placed high up on their bodies to be on the lookout. They're on the lookout at the entrance of burrows. The burrows are dug by shrimp. Hence, both animals work together and greatly enhance their chances for survival. The goby is looking out for dangerous predatory fishes, whereas the shrimp digs a burrow. This is a sap-sucking slug. This animal takes the photosynthetic organelles of the algae it feeds on and keeps them alive, and keeps them doing photosynthesis in its body. Another intricate way of two organisms working together. This is a feather star, a crinoid, a mid-sized invertebrate. And who is living on it? This is a crinoid squat lobster, one of several crustaceans which have made these crinoids their homes. The crinoid squat lobster never leaves the crinoid during its whole life. And look at the coloration and the pattern of this animal. It's completely adapted to be camouflaged, and camouflaged only on its invertebrate crinoid host. This type of working together is very often encountered in the muck. What do we have here? This is a fire urchin. And here we have a small cardinal fish. The otherwise harmless and vulnerable little fish uses the fire urchin as a fortress. The dangerous and in fact also venomous spines of the urchins protect the fish during the day. During sunset and sunrise, the fish ventures out and uses its light-emitting organ to hunt for tiny crustaceans. Again, a fascinating way of working together between two animals. Whom do we have here? That white animal here, is that a worm? No. This is actually a pipefish. This is a mushroom coral pipefish. So, this large invertebrate with all these tentacles, even though it looks like an anemone, is not an anemone. It's a mushroom coral. It's living in the sand, and it's one of these corals which has only a single polyp, in contrast to most colonial species. It's home to a very unique type of pipefish. If you look at the coloration and the elongated shape of that pipefish, it very much looks like the white lines at the base of the mushroom coral. Another example of a greatly fine-tuned way of animals living together in the muck. And we're back with our friends, the fire urchins. This time there's a slightly bigger fish which is hiding in it. This is a juvenile red emperor snapper. Of all snappers, only the red emperor snappers hide in these fire urchins, and they only do it as juveniles. When accidentally dislodged by a careless diver from the home urchin, they very quickly rush back and hide in between the spines. Nobody in his good mind would want to grab that fish. Look at all these dangerous spines protecting the little snapper. This is a fascinating symbiosis, and I've actually only seen this 3 times in several thousand dives in the muck. The more you look, the more you discover. Another close-up, and there are even 2 red emperor snappers at home in one fire urchin. What an extremely safe way of spending the night. Symbiosis can very often make the difference between life and death for animals in the muck. Here, the little fish seems to be attacking my camera because I came too close to its home fire urchin. Finally, we have a juvenile jackfish which uses a pufferfish as a hunting aid. The pufferfish digs in the sand for invertebrates, and the jackfish is a predator of other fishes, which might not see it behind the pufferfish. Amazing. A tube anemone in the muck, in the middle of a sandy plain, its tentacles ready to grab any plankton drifting by. There's a is a hydroid, another animal related to a jellyfish, but sessile, growing from the ground. They're all eating other animals. Other animals' bodies are rich in nutrients, especially in protein. To quote David Attenborough, eating other animals, a good job if you can get it. Now, how are you a successful predator in the muck? It's not a trivial job. Just like them, there's no way to hide for the prey. It's also easy to see you coming. The muck fauna has evolved a few strategies which are successful. One is to lie in wait in your burrow, like this mantis shrimp. Mantis shrimps are crustaceans, only distantly related to conventional shrimp which you might eat in a restaurant. Look at the interesting pseudopupils moving around on the eyes of these animals. This one has very sharp, powerful vision, and it's going to grab anything that comes close to its burrow. It can disappear in the burrow, and even when its head is sticking out, its color is camouflaging it. Even though they're probably the size of a small person's hand, they're very easy to miss because of their great camouflage. Another predator here. This is a snake eel, and it's using a strategy which we also have already discussed. It disappeared under the sand, almost all of it. The eyes are sticking out, and the mouth, a mouth full of powerful teeth, ready to grab a small fish coming by. This might be the last thing a little fish sees or feels before being eaten by this keen-eyed fish. Most snake eels don't move at all. They spend their days perching in the sand, looking for the prey to come to them. This is a strategy which both saves energy and which works well in the muck. Some snake eels have really comical faces, like old men desperately trying to tell a story. This is a flathead. It's another predator which mostly buries itself in the sand and waits for prey to come by. And of course, no discussion of predation in the muck would be complete without frogfishes. And what we are looking at here is a very unusual example of predation in the muck. I was very lucky to see this interaction between two species of mollusks and a fish, whereas the fish lost. So what happened? You can see a flounder, and it's paralyzed, maybe already dead. A cone snail, a gastropod mollusk with a very powerful venom, surprised this flounder in the muck and injected it with its powerful neurotoxin. You see the flounder in the middle of this scene, curled up. Covered in red algae is the cone snail, highly camouflaged. It's starting to eat its prey. Now, it's not alone during dinner. Instead, a couple of murex snails, probably guided by a very sharp sense of smell, also converged onto the dead flounder. And so there's a feast now, with the cone snail inviting and the murex snails as guests. Very quickly, that flounder will be eaten up and there will be nothing left of it. So this is one of these rare cases where an invertebrate has surprised and killed a fish, a vertebrate. Normally, fishes are too fast and too clever for this to happen. Here the element of surprise and a very powerful venom have done the flounder in. The murex snails were in a great rush, and they were what initially alerted me to this unusual piece of natural history. There's another gastropod snail trying to attack a sea cucumber. And what did the sea cucumber do? It emitted these sticky and at least mildly poisonous strands out of its rectum. You can see the sticky strands on the left coming out from the sea cucumber. The snail is already discouraged. It's at this point probably more trying to get away from the cucumber and its defense mechanism than trying to feed upon the baby sea cucumber. Not every act of predation works. Here there's a close-up, and right in these moments the strands dissociated. Finally, this is a successful act of predation, but a prey animal which did not give up. A manila puffer is feeding on a hard urchin. This is one of the sea urchins which lives most of its life dug in the sand, a very typical part of the muck fauna. The pufferfish has already eaten a big part of the sea urchin, but by their unusual anatomy, the sea urchin is still capable of running away, even though a big part of its body has already been chewed up. Predation, always a drama, especially curious in the muck. Congratulations, critters. After all these struggles, you have won. After hiding, after camouflaging yourselves, after becoming venomous or poisonous, or after hiding under the sand, you may now reproduce. These are two sea slugs, two plurobranchs, mating. These are rare animals, and I was excited to see them, and I was excited to see them mate. These are hermaphrodites. Each animal is male and female at the same time, and here at this channel they transfer eggs and sperm to each other's bodies mutually. The next round of critter life in muck can start. The same for these fire urchins. These are generally considered broadcast spawners, emitting the eggs and sperm into the water column. Here, the white stuff coming out of the sea urchin, that's sperm. It was quite striking during this encounter that they were not randomly emitting their gametes into the water, but they walked at high speed very close to each other. If you're that spiny, nobody will come between you and your partner. What beautiful animals, and I'm glad there will be more of them in the future. This was the story of muck. I hope you have enjoyed this. I hope you've learned something, and I hope you consider all of these critters in the muck acquaintances or even friends. And since this is YouTube, please support my filmmaking by subscribing, liking, and leaving a comment. You can directly support my filmmaking via the PayPal listed below, or you may buy my books. They're about scuba diving and marine animals. They're all listed in the description. Thank you so much.